Okay, so picking up this where we left off on that earlier video, just a quick rehash on number six. The Ogallala Aquifer is this enormous amount of water underground in under the Great Plains, and it's water that accumulated over millions of years, and it's being pumped out at unsustainable rates. And what the whole point of number six is, if we regenerate our soil in the way that is described in Montgomery, we can reduce soil erosion. We can increase the water infiltration rates of the region and the water holding capacity of the soil. We can improve the root access to moisture through healthy rhizosphere-based hyphae. And so doing it this way, regenerative agriculture can reduce the need for unsustainable withdrawals from ancient groundwater reserves. So it gives you that a high carbon soil gives you that stable kind of soil environment where when it rains too much, the soil still can hold the moisture. And when it rains too little, the moisture loss from the soil is much less, and there's some more water storage there in the first place. And so we end up with a soil that still can support crops, and we can tap into that water and that unsustainably pumped water of the aquifer less. Okay, so all pluses. Number seven, farmers are caught in a revenue trap with increasing input costs and depressed crop prices. So this is something that takes on some other dimensions, and I do have some other stuff on this in this unit, but let's just read through this. So farmers are trapped in an agrochemical input treadmill and rising crop losses due to pests and other pathologies induced by agro-ecosystem imbalances. Overproduction has caused falling commodity prices, forcing smaller operators out of business. Okay, and I've got a graph, two graphs elsewhere that talk about that. Rising costs take a greater share of total revenue or even exceeding it. By the way, this clickable link for some reason went kaput on me, but there's a graph that shows that anyway in our other unit, or in one of the other units here. So don't worry about that clickable link there. About 90% of income in North American farm households comes from government payments and off-farm income. Think about that for a moment. How can we have a system where it's mostly government dole and someone working off the farm to support the farm? That is much of the households in North America. The average age of farmers has risen from 50 to 58 years, suggesting a lack of interest in young adults. And this is just a link to the modernfarmer.com magazine where they talk about such things. That link won't get you to that statistic directly, but that's where I found it. You can search within that if you're interested in follow that story, but you don't need to for the purposes of this. Just be familiar with this. So what's going on? Young people don't want to farm anymore. It's so unprofitable. Go find something else to do. That's a lot less hard work. Regenerative agriculture substitutes cover cropping and multi-year crop diversity. This is all stuff in Montgomery, our reading, okay, to improve soil health and biology. Pests and nutrient supply are managed through improved soil biology and near zero use of fertilizers and other agrochemicals. Due to dramatically lower input costs and still adequate yields, profit and interannual revenue stability can be achieved. Now, if you click on that link, it's a 2.5 hour video. I don't expect you to watch that, okay, all of it. I'm going to give you some pointers on some of that video later, so there'll be a posting I do. This is actually June 2nd today, on Tuesday, when I'm talking with you right now, when I recorded this. But I will post something about the video that links to later. So don't worry about clicking into that now, but that's where that information is. I'm just going to give you some highlights to look at in that video. That's probably the last thing that I'll post for this unit. So accordingly, regenerative agriculture is, as configured to local conditions, can be profitable in smaller farming units than typical for conventional farming operations. That's all described in that video up above. Regenerative agriculture uses nature's services rather than purchased inputs from the agrochemical industry. Okay. So this is a way to kind of go back to nature, but we know a few things we've learned, and we can do this, and it's being done in a large part of the Great Plains now. This is a very big trend. Really exciting stuff. Haven't seen as much of this in the Northwest. It's something I'm interested in looking into. So then finally, point 8. Yet, with all these problems that I've described, many of them are related to climate change, not all, yet we keep putting more carbon dioxide into the atmosphere through fossil fuel combustion. So this is a quick graph, just as a reminder for us. The theme of this is clear. Wow, look at that graph. That shows from, and by the way, again, this is, you probably remember how this was generated, right? So how do scientists date the Earth? This is the ice bubble research done in the great ice sheets over Antarctica and Greenland for the most part, piecing together carbon dioxide levels over time. Here's what's found over and over again. All over the world, you see the same up and down pattern, closely correlated. Look at this. We are now in record territory, and we are destabilizing our climate. We've seen huge impacts of that, the loss of our coral reefs, the destruction, or at least the temporary destruction of the kelp forests, for example, in much of the Pacific coast of the North American continent. Wow. So this is a fact, and what's exciting is that even this problem, to some degree, can be addressed by soil regeneration. How? By sequestering carbon dioxide from the atmosphere and reducing or eliminating the use of fossil fuel-based commercial fertilizers. Studies suggest that somewhere from 10 to 80% of current fossil fuel carbon emissions could be reduced and offset through regenerative agriculture and ranching practices. 10 to 80%. Sounds like they don't know what they're talking about. Well, okay, that's a reasonable statement to make. But what this is, it depends on the assumptions you use about how aggressively we do this on the world's croplands and rangelands. And so depending on how that plays out and how we are sourcing our energy use in the future that's related to food production, there's a pretty wide range of what could be possible. But if you take a really conservative, maybe 20% or so, that would have an enormous impact. That's roughly like taking all of the motor vehicles off the roads in the world. Yeah, that is a huge number, isn't it? Just to give you a ballpark on that. So there's some real possibilities here, and much of this is why I've had to read Montgomery, his work and his wife's work, a lot of it, and also the whole green manuring chapter, because it talks about these kinds of techniques, and we can solve or begin to solve a whole bunch of problems and also make life better on farms themselves. So hope you find this uplifting. I know very few of you are from farming families, but I'd love to hear from you if you are from a farming family. I grew up that way, and in fact, my first 10 years of my adult life, I made a living farming in Eastern Washington. And I just ran into geography when I was working on my bachelor's degree part-time. Loved it. I couldn't get enough of it. I ended up selling my farm. I went off to grad school, got my doctorate, never looked back. I really love my work, but I do miss the land, and it's really, really fun to see what we've been learning. I knew quite a bit of what we've shared with you in this unit, but not all of it, not enough to really have changed my situation back when I was more of a college-age student like most of you are. So hope you found this part interesting.